how fast? Okay. All right, then I would say welcome to my talk. As you see it on the screen, my talk is about charting capabilities in Eclipse or in general in Java. And it was a while ago, so since a few years, there are a lot of new fancy charting capabilities with JavaScript, and when you have a look at those, you think, okay, maybe we Java people are the losers. We do not have that much of charting capabilities as these fancy stuff we can do with JavaScript, but it isn't. We have a lot of there are a lot of good tools and there are a lot of good libraries, but the problem is that sometimes you have to do a lot of manual coding, a lot of adjustments to do the charts exactly that way you like to have them. And what I would like to present today is a way that you can reuse charts in an easy way, in a compact way, and you can, even though you can extend them to your own needs. And what you see here is, for instance, it's a line chart, it's a chromatogram chart. You see we have a lot of series, we can zoom in, we have a scroll bar here, we can go through the data sets. These are data sets are normally analyzed, so we have a couple of peaks, you have to find, let me see, okay, no, not this one. This one, this unique peak you have to detect in such series. And as you see, it's hard to do those stuff, but the most important thing is that we need a good charting, because we humans much better understand charts than series of data. And when you have a look at the data sets, I can show you here in my IDE. The data looks like this. We have milliseconds, we have intensity. So you have XY data, it's nothing more. Where does it come from? So as the title says, charting, the making of, is, I give you an impression where we came from. So this is my application, OpenChrom. It's about chemistry, about forensics, it's about data analysis. Charting is very important, and it was back to 2007 where I started the project initially, and I searched for charting tools, and you always ever have the choice to say, yeah, let's do something on my own, let's use other libraries, and first I thought, okay, maybe write my own library. Then I thought, okay, it's too complicated. I searched a bit around in the open source world. And finally, I found a link to this library. I don't know who of you is aware of SWT chart? A few hands going up. It's a lightweight library written by, his name is Yoshitaka. I contacted him a while ago, and he produced a really pretty good library. It's lightweight, it has a lot of capabilities. When you have a look at the screenshots here, we have line series, we have bar charts, we have scatter plots, we have logarithms in there, and multiple axes, and so on and so on and so on. Great library, and I thought, okay, I will take this one to do my own charting. People ask me, okay, why haven't you used XY chart or XY graph and all this other stuff? There's no answer. I just took this one, so it has no reason why I didn't take the other ones. But what I saw over the years was, let me go back to my application, that I extended the charting to my own needs, and I'll give you an overview here. What I effectively need is something like this. What you saw before was a chromatogram. We have a chromatogram in this chart too. Maybe let's enlarge it. Then we have peaks, we have chemical names, interesting for me, sure. We have unselected peaks, we have what we see here. We have identified scans, selected, unselected. We have, I can go here, we have a baseline under the peak, we have the scans, and so on and so on. So that was what was a thing I've implemented in OpenChrom over 10 years now. And the main decision was then to say, okay, I have created all this stuff. I made a lot of mistakes doing it. First I thought, okay, charting can't be so difficult, but sometimes it is, to get all this interaction, to update the data and all stuff. And then a while ago, it was a few years ago, something really interesting happened. And this interesting thing was this one, the Science Working Group. At the Eclipse Foundation, we started the Science Working Group. It's a research group of different people, a lot of great scientists, research institutes, companies, and so on. And we said, hey, let's group together because we all have the same problems. We have data, we need algorithms, we need matrix operations. That's what we also have now with Eclipse January. It's hard to pronounce for German, but it works after a while. It's for matrix operations in Java, which was not available before. And the third big thing is charting. And so I thought, okay, I can use my knowledge I've gathered over the last 10 years with these charting capabilities and make it independent of OpenChrom. So that you don't need to install OpenChrom, that you just need a small charting library which extends SWT chart. And the result can be seen here. We have, under the umbrella of the Eclipse Science Working Group, we started another project. It's called the Eclipse Advanced Visualization Project, another tongue breaker for a German guy. Jay introduced the name, and as the name says, we have visualization capabilities in here. So you see three-dimensional things, you see one-dimensional, two-dimensional things. There's a reactor or something like that from Jay, and so on. And so the initial, or the main reason was then to say, okay, I extract my capabilities of charting and put it into EAVP. And you can simply go there. It's under Eclipse EAVP and can download the source code. You have to switch to the ChemClips branch at the moment because we do a lot of developments, and hopefully we merge this back into the master branch in autumn for the next release we do with the EAVP. And the interesting libraries for you are the service SWT chart libraries, and I can show you in the workspace. They make it smaller. They are here. What you effectively need is this one, SWT chart, nothing more. All charts are contained here. I've created the demo application, which can be seen here. So you can use both plugins and start with a normal Eclipse application. So what you previously saw is that I've created some perspectives which contain part stack, which contain several line series or bar charts and so on. I will soon show in detail. And sure, we also have some testing, but let's go back to the charts. This one, it's here. So you see, we have a line chart. It's a line series, so it's common. It does not depend on if we have FID detectors or MSD or X-ray diffractometry or something else. We see line series, and in line series we have peaks and so on, so we can reuse it in several facilities. But what you see here is, as I showed before, we have a scroll bar, and the scroll bar is not available in SWT chart. So it's an extension, or it's an additional value we put on to these libraries. What we also have is, I'll show you the code, you see we have the scroll bar here, is that we have convention over configuration. So to get this line series number 4, what you see here, is simply you have to write this code. and I show you here. That's it. Go top, we create the chart, we say our part extends from chromatogram chart. We make the initialization, and what we do here, we add the data series from data series 3 to 7. We can get the settings for the line series, and here we say, okay, get a line or set the line color red, black, gray, dark red, dark gray. Enable the area and add the data to the data list. So when you have, sure, these are only a few options we can set. When we say line series settings here, set, you see we have a lot of additional values we can set, like symbol size, symbol color, symbol type, and so on. You can modify it in a way as you like, but if you use a standard set, it's pretty simple to use the library. But before I go into details, I would like to show you all the other charts. So what you see here, we have saw this before. Was quite a work to put it rotated, but after a while I saw, okay, there's a GC graphic context operation which says transform this text by 90 degrees. Was easy then. Line series 2, this is also an interesting one. What you see here is again a chromatogram, but we have now multiple axes. Normally the data is what I use as a data set, XY data set. X is a retention time stored in milliseconds, but nobody wants to see milliseconds. It's yeah, we can't, it's too complicated for us humans. We know we can handle minutes or we can handle scan numbers, which is much easier. And I did the work to add additional axes, and the problem was SWT chart. Oh, it's not a problem, it's a great library, but to handle different axes means that you have to translate from the original millisecond value, in this case, into minutes. Okay, it's a division by 60,000. Or you have to handle it into scan number. That's a bit more complicated, because then you have to know the scan interval and the scan delay in the beginning for these data sets. But it's possible, and my library is now taking care of all these issues you don't have to take care of. What we have minutes, scan numbers, we have intensity, we have relative intensity, and we have something on top which called range info or range setter. And it automatically extracts which the number of axes you have set to your charting library or to your chart you've created. So for instance, let's say minutes, or no, let's say scan number. I want to do a selection by starting at scan number 6000 up to, let's say, 7200. And in intensity, let's say, okay, it's a total intensity. Let's say we use a relative intensity up to 0.5. And then we can select the range exactly as we want to have it. And if you make a mistake or made a mistake, you can reset the settings, you can zoom in again, or you can hide it. So sometimes you don't want to show the range info. You can also define in the settings whether you would like to have a range info at all or no range info information. If it's set to true, then you can double click on top and bring it into the front again. So that's quite handy when you would like to set specific ranges. What we also have in here is, this one we had before, is the line series on the right side. So sometimes line series start at 0, 0, so we have no negative values, and we don't want to have negative values. In this case, it's an NMR signal from a nuclear magnetic resonance detector. We have to Fourier transform these signals too, but this is the raw data, and you see, okay, we have negative signals, we have positive signals, and we can zoom in and zoom out, but say, okay, at 0, that's the border where you can't go to the negative area of the X values. What we have here is a bar series, also used in OpenChrome. It's a mass spectrum, but it's a generic way, so you can reuse it also in other applications where the MZ value, the mass over charge value, is displayed on top of the 5 highest intensity values. And you can not only use this one with the integer values, it's also available with the high resolution values. Okay, that's not high resolution, but you could display exact values there. Or this is another way how to display it. It's a specific approach. It's a triple quad instrument where you have a precursor ion and a daughter ion and so on. But it's chemistry. I don't think that you're interested in it. What I would like to say with this, you can label the things as you like. So you can put specific label information there, and then all the things are printed as you like to have it. One more thing, what we saw here in the top, we have a menu, but it's not working yet. But as Torkel is working on the LaTeX integration into Eclipse, we will hopefully soon have a command which exports the chart data into TeX format, so that you can directly work with LaTeX or to BNG or other things. But the menu is not working completely yet. It's a work in progress. And what we have in here is we have a compression algorithm, because sometimes when you have my data set, I have 100,000 measurements per data set or more. It's getting slow with the UI. So you need a pre-compression of your data, and SWT chart is doing a compression of the data. But I also do a compression before it goes to SWT chart, because we had this case, it got slow, and I pre-scan or I filter out some values so that it's very important that charting is fast. And that's what you also see at the example number 4. We have this mass spectrum that's from a TOF system, as a time of flight mass spectrometer. You get from one measurement nearby 300,000 measurement points. And what you see, it's fast. So you can zoom in, you can have a look at the values, you can zoom out, you even can plot the highest values on top, so that's fine. The next one is a chart, a scatter plot. It's known for PCA as a principal component analysis. It's also available in there, so it's pretty easy to configure. What we have next, before we go into the code, is a linked editor. That's also pretty handy, because sometimes you want to link data together. In this case, both charts show the same data set, but you could also display reference data and the database set or a sample and so on. And you can simply link those editors together. And the interesting or the nice thing is that when you zoom in on top, it automatically arranges the area in the other plot. And it's not only that you can have a one-to-one link, you can have an M-to-N link. You can have several editors which are linked together. And what I've also implemented as an improvement is when you select a too small range, then now it happens, but normally then nothing happens. We had this, it was incidental zooming. People said, okay, I clicked on it and then it zoomed in, it didn't know where I am. That can't happen, because he says, okay, you need at least 1/30 of the total range for your zooming area. Unless if you're lower than that, then it won't zoom. And what we see here, we can have also scroll bar in the bottom, so it works fine. The next example is this one. It's the record thing. People ask me also sometimes, okay, can we use the charting to have a live recording of data? And sure, this is now not a live recording, but I can say record new things. And now he's doing random data. We have no real signals. But these libraries could also be used to have a live recording and see what's happening with your detector. And it's pretty easy. So let's go back to the main or to the main perspective. This is, no, we don't do it. I show you the linked one. The linked one is this one, and it's quite easy. Let's go into the code. We have it here. So again, you say, this is my part. I have a composite. I have a linked series, and let's have a look at the linked line series, where you just say sample chart, add linked scrollable chart, the reference, and the reference links back to the sample chart. So you can have the flexibility to do what you want. How is the library at all designed that we say, okay, we have, for instance, a look at the scatter series where we put in our scatter data, and this extends from PCA charts. So we have, I just minimize this one. Hopefully you can see it. This one I can. No, this can't be enlarged, so hopefully you see it. What we have in here, in SWT chart, we have some custom charts. So principally what we have is line series, bar series, and scatter plots. And what you see here is, for instance, what you saw before, a demonstration of a line chart. It's a chromatogram chart, where we set the orientation. It's horizontal, where we say we want to show a horizontal slider. It's visible. The vertical slider thing is something interesting because it's enabled, or it's there, but I have disabled it by default because we have an option in SWT to say right to left or left to right. And the funny thing is, whether I use left to right or right to left, it's always the same. When I go down, the chart scrolls up. So it's a complete opposite behavior of what you think it should be. So that's why it's disabled for now. Hopefully we will fix the bug in SWT and it will be enabled later on. But unless it's not fixed, I will not show it. We say use 0x or 0y. And here we say, okay, we want to define our axis. We said set primary axis set. That's what you see here. We have our primary data is milliseconds. We want to have a decimal format stored there, like scientific format or integer or something else. You can define it by your own. We want to show it with the color of black. We have the position. Secondary position means it's on top and it is not visible. So we say, okay, the axis is not visible by default because you don't want to see milliseconds. It's too much information. Grid line style is none. I can go back to the chart. This is a grid line style, you see, to have a better view at your data. Then we do the same for the y-axis. It's intensity, decimal format scientific, and line style none, but it's visible. And then we set the secondary axis set. And what you see here, the primary axis, x and y, they are always there. So you don't have to create them, you just retrieve them from the chart. But you can add as many secondary axes as you like to. And what you see here, we create a new one, create a new secondary axis. We can give a label for the axis. And we say we want to have a milliseconds to minute converter. Because the chart then knows how to translate milliseconds to minutes and minutes to milliseconds used for this range info setter. Let's have a look at it. It's quite simple. It implements the axis scale converter interface, which says convert to secondary unit or convert to primary unit. And the only thing we do here is saying primary value divided by minute correlation factor or multiplied by it. But when we go back, we could also have more fancy converters. And you see it here for the secondary axis, it's the relative intensity. And let's have a look in here. We say, okay, orientation. We say, is it zero based? That's very important. If the value starts at another value than zero, because that affects how your percentage is calculated. In this case, we say yes, and then these convert to secondary unit gets the chart data coordinates, because when you store the raw series, it stores the min and max values in the chart. So you can simply retrieve them over the chart coordinates and make a calculation. Yeah, it's a simple mathematical calculation how to translate between relative and total intensities. That's it. So we can easily define our multiple axes. Let's have a look. I would like to show this one. We've shown this one before. Exactly, we go back to the PCA chart. It's effectively the same, but there you say, okay, I extend from scatter chart. And what you see in here is you have the custom charts and you have sub-packages for bar chart, you have a sub-package for line chart, and you have a sub-package from scatter chart. Let's have a look at the line chart. It extends from scrollable chart, which means that you have the scroll axis and all the stuff. It's the same for the scatter chart, and it's the same for the bar chart. And as we don't have so much time at a 30 minutes talk, I could show you all the stuff we have in here. For instance, we have a new, the scrollable chart contains a base chart, and the magic happens in the base chart where a lot of operations are done to say, okay, is the user selection in the correct range? Can we convert the values? Where do we have the correct areas? And so on and so on and so on. So I think this, having a look at that, confuses more than it's interesting for a 30-minute talk. But what I want you to show is, or give you the impression, let's go back. Show view. No, it's not the view show, it's a demo perspective. View is the overview. What we see here is that we are pretty flexible what we do, and I would really love to see if you include these charting capabilities into your own application. And now we have a really lightweight library which you can include and which you can use and extend for your own purposes. Yeah, I have a look at the time. We are nearby over. At the end, who likes can get a sticker from Chrome. I also have pens. I didn't mention this before because then you wouldn't have looked at my charts. And so I think we have a few minutes. Whoops. I think we have a few minutes. Are there any questions? Okay, yeah?
Do the converters, like the millisecond to second, do they convert the data or only the values on the axis?
They convert the values on the axis. So what you give in is XY data, for example, milliseconds intensity. And he's not converting the raw data which comes in. He's only say, okay, I start at millisecond 300,000 up to millisecond 800,000, and then he converts both values much faster than doing a translation of the underlying data. That's what you don't want. As we are based, we simply or just use SWT chart, and SWT chart uses SWT. Probably yes, but I've not tested it yet. So if you like to give it a try, sure, then we can have a look at it. Yeah.
I have a question. Like, does this chart can provide custom tooltips where I can customize the tooltips and pre-processing and post-processing? Once the chart is generated, after that I hold my mouse pointer on some point and see much more data and dividing that particular data point.
Yeah, that's definitely possible. And I can show you in the code. So what you see here, for instance, printing the labels on top of the peaks is a custom operation, and I can show you here in the code. It's just too many things open, but we have the demo section here. We have the demo parts. It's the line series part 1, and what you see here is, I go to the, okay, there we add such more data. And here we say add series label marker. And what you effectively do is say, okay, please get me the plot area and add a custom paint listener. And each time the library is rendered, he calls this custom paint listener. And there he says, okay, please give me the rectangle, please give me the labels which are in this rectangle, and draw them on top of the peaks. And this graphic context set transform method saved me a lot of time. By that, you can also print your own text and labels and information there on demand.
But that is a static level. I'm talking about a tooltip. Like floating tooltip, is it possible there also?
You can print everything you want onto the pixel points.
Yes, as in when you hover over.
Sure, you can do it here when you say set symbol type, plot style. I think it's something like cross or plus or square, and you can then implement methods to say, okay, put if you just if you are with your mouse on the hover of such element, then show a tooltip. Yeah, that's possible. Yeah, further questions? Yeah. It's not available as a binary build, but you can go to the web page to Eclipse EAVP at GitHub from Eclipse, and then download the source code and check out the SWT chart packages. So by that you can use it. But what we want to do is doing a binary build by end of the year with the science release, and then it will be available as a jar library via Maven or other systems. Yeah, further questions? Not so far. Then I would say thank you that you listened. Now I can drink my wine, and I hope you enjoy the Eclipse conference. And don't forget to vote.